Hi, I'm Craig Rowland, founder of Sandfly Security. In today's video, we're going to discuss SSH authorized keys being given to Linux default user accounts. Now, this is a persistence mechanism used by attackers on Linux. There are a lot of ways for attackers to maintain persistence on Linux. They might add a new account. They might change a password on an existing account, although that's a bit obvious. They might simply drop an SSH key onto an existing account that can allow login and hope you don't notice it. Or they might add an SSH key to a default user, and I'll tell you why. It's a bit surreptitious because most of the time, most people are not looking at the default users and what they have going on because they just assume those people can't log in. But as I'm going to show you today, it's actually quite possible to make a user login that doesn't look like it's very odd. First, we're going to go to the Sandfly user interface. Now, Sandfly is an agentless endpoint detection and response product for Linux. We can monitor virtually any Linux system without loading any endpoint agents. We also do SSH key tracking, password auditing, drift detection, and more. But for today's demonstration, we have scanned one of our systems here, and we found a problem. This host here is called Sandfly Victim, and we found two things. First of all, we discussed this in another video. We found a default user account called Games has given themselves a shell. I'll talk about that in a moment, but it is fully addressed in another video. But the main reason we're here is we found a default user called Games, and we said that the default user Games has an SSH authorized key file present on the directory. This is a system default account and normally shouldn't have any SSH keys to allow login, right? Pretty self-evident that there's something going on. If you look at the raw data around what we collected here, you can get more information about it. Everything about the username, what their shell is here. I could see here that it's supposedly the password's disabled, but I'll tell you why that's not important here in a moment. But down here in SSH authorized key file, it is present. We have what the key is. We also have this information here about when that file was created, and this can help you bracket when the incident might have happened, assuming, of course, that the attacker didn't timestamp it. But a lot of times they don't, so this can give you a really good way to know when you should start looking at this host. But let me switch over here to terminal land because I think that there's some interesting things we could show you about this. So I'm here in my terminal now, and I know it's called the games user, so I'm going to go to my games directory. I do a listing here, and I do see that .sh directory. It's the only thing present, so it's very suspicious. If I do an LSAL in this directory, I see my authorized key file, which of course we wanted to see here because that's what was identified. But we also see that there's a public key here, ID RSA pub, and it's owned by root. What this means is that this person had root access, that they added this key to the authorized key file. Now on Linux, I don't care what you've done to secure the host, you should just assume if someone has gotten onto that host that they have obtained root access. Just assume it. That way you won't be disappointed when you find out it happened, because I guarantee you it's going to happen. Okay, in this case here, we know it's root, we have timestamps, we have the authorized key file here, and my authorized key file also shows me that with the comment that this was likely made on this host here called Sandfly Victim, but we know that someone has put an authorized key file. Now, why is this sneaky? Well, if I look at the etc password file here, most of these default accounts have a shell called no login. So if you tried to log in with this, it simply says you can't log in and it kicks you out. But if I look at my games user here, there's something interesting about it. Someone has actually used the change shell command, and they've given this a login shell of bin bash. So this was done with deliberate intent. But what's also interesting about this is if I count out the etc shadow file, you see here again that it looks disabled. So if you're simply looking at password files, you're going to think that this account is disabled. You probably didn't see that it had a shell on it. You're definitely not looking under the user games directory for a .sh directory. So this is a very, very sneaky way to maintain persistence on those boxes. This is what we call a dormant attack. A dormant attack is different from what we classify as an active attack, because an active attack is going to be something that's in memory right now. And a lot of people focus on that, a malicious process or this or that. And that's all well and good, and we do that too. But there's a whole other side to Linux attacks that are dormant, meaning that it was something that was done to the system that's not active in memory. This is an example of that. This account can sit here for months, potentially years, before anyone would notice it's there, and it's only going to become a problem when they come back to actually use it. But otherwise, if you're just looking in active process space, you're never going to see this type of activity present. And even if you're monitoring events happening on the boxes, it might go completely unnoticed in the raft of noise you would get from looking at these things. So you really got to go out and hunt for this stuff directly. Something else, though, that we do that might help you out in this area is not only do we give you these active alerts, and this is too much for me to get into this video today, I'll just touch on it really briefly. We actually track the SSH keys. So when this key was added, we actually tracked it here and said that there's a user here called Games that actually was given a key. So now at this point here, you can see who that user is. I can see their key. I can see also what hosts that they have access to. So it helps to really close the loop in terms of what's going on with users having unauthorized SSH keys. So anyway, that's a brief example of default users on Linux with authorized keys file for SSH. You should never see it. If you do see it, just assume the system's compromised. So if you enjoyed this video, check out our other videos as well. We cover a lot of Linux intrusion detection and incident response topics. I'm Craig Rowland from Sandfly Security. Thanks so much for watching this video. I appreciate it, and goodbye.